Good morning, students. Today we will discuss electric potential, which is again the part of your first unit, electrostatics. Electric potential is a very important concept. Okay. What is electric potential? It is the scalar representation of the electrical environment around a source charge. It is also a point property like electric field intensity. Electric field intensity is the vector representation of the electrical environment around a source charge, whereas electric potential is the scalar representation of the electrical environment around a source charge. Okay, mathematically it is the ratio of work done in taking a test charge from infinity to a point divided by the magnitude of the bringing charge. Suppose potential at any point P, Bp is equal to W infinity to P divided by Q naught. Here W infinity to P is work done in taking a test charge Q naught from infinity to P. What is the basic difference? Electric field at any point P is the ratio of force experienced by the test charge placed at that point P to its magnitude, whereas potential is the amount of work done in taking Q naught charge from infinity to that particular point P to its magnitude. Okay, so what we did, if we wish to calculate the electric potential at any point P, we have to bring our test charge Q naught from infinity to point P. We will calculate the work done in taking Q naught from infinity to point P, whereas to calculate the electric field we simply put the Q naught at the point P and we will calculate the force experienced by the source charge at the Q naught, and then we divide this force by the magnitude of Q naught. We get the electric field intensity. Okay, so please keep this fact in mind. What is the basic formula to calculate electric field at a point? That is force per unit charge. Here potential at any point is the work done per unit charge. Okay, so potential basically is work done per unit charge, whereas electric field intensity is the electric force per unit charge. The unit of electric potential is volt or joule per coulomb. Dimensions you can calculate. V is equal to W upon Q. W, dimensions of W numerically equal to the energy m L2 T minus 2 divided by 80. So finally we have electric potential is m A minus 1 L2 T minus 3. Now physical significance of electric potential. Write the formula. Vp is equal to W infinity to P divided by Q. We take Q is 1 coulomb, so Bp is equal to W infinity to P. It means electric potential at a point P is defined as the amount of work done in taking 1 coulomb of charge from infinity to point P. Okay, next. Electric potential is also the measurement of the electrification of a body. It is a scalar physical quantity which determines the flow of charge. electric charge always flows from high potential body to low potential body. Electron always flows from low potential body to high potential body. I already discussed regarding the motion of electron. Okay, so basically electric potential is the degree of measurement of electrification of a body. It basically determines the flow of charge. Electric charge always flows from high potential body to low potential body. Now we will calculate the electric potential due to an isolated charge Q. You can see in the diagram there is a isolated source charge Q placed at point O, and there is a point P at a separation R from source charge. At this point P, we have to calculate the electric potential. Okay, so to calculate the electric potential at point P, what we do? First, we will calculate the work done in taking a Q naught charge from infinity to point P, and then we divide that work to the magnitude of the Q naught charge. Okay, so you see the path of Q naught from infinity to point P is a continuous one. Okay, we will break this path into very small infinitesimal path elements. Displacement of each path is dx. Okay, we take at any instant Q naught is at a location A, which is at a distance x. Okay, Q naught will feel force of repulsion due to Q, which is 1 upon 4 pi epsilon naught Q naught upon x square. Okay, suppose you take Q naught from A to B at a very small displacement dx. You see here the force of repulsion and the displacement are opposite to each other. Okay, so for calculating the work done in taking Q naught from infinity to P, first we will calculate the work done in taking Q naught from A to B, which is F dot dx. Okay, so again, by the definition of B at P, this is the simple formula. Bp is equal to W infinity to P divided by Q naught. This is equation number first. Now we will calculate W infinity to P, which is amount of work done in taking Q naught charge from infinity to P. We will calculate this work done with the help of vector calculus method. This is the vector calculus method. What is the meaning of vector calculus method? The method to calculate the work done from infinity to P. For this purpose, we first calculate the work done in taking Q naught from A to B. Then we will integrate this work from infinity to P. Okay, mathematically W infinity to P is equal to integration infinity to R F dot dx. You see F dot dx is F dx cos of pi. Cos of angle between F and dx are pi. So W infinity to P is equal to integration in infinity to R F dx cos pi. Cos pi is minus 1. So this is minus infinity to R F dx. We put the value of F. W infinity to P is equal to minus infinity to R Q naught upon 4 pi epsilon naught x square dx is equal to minus Q naught upon 4 pi epsilon naught. We take this from integrand. Q naught upon 4 pi epsilon naught is treated as a constant. So this can be taken out from the integral. So this is W infinity to P is equal to minus Q naught upon 4 pi epsilon naught integration infinity to r x की power minus 2 dx. The integration of x की power minus 2 dx is minus 1 upon x. You see, w infinity to p is equal to minus q naught upon 4 pi epsilon naught, बड़ा bracket minus 1 upon x infinity to r, and finally you solve this. Okay, what you get, w infinity to p is equal to q naught upon 4 pi epsilon naught r. Take q naught in the denominator of w infinity to p. W infinity to p divided by q naught is equal to 1 upon 4 pi epsilon naught q upon r. And finally you got the electric potential due to an isolated point charge at a separation r. Bp is 1 upon 4 pi epsilon naught q upon r. Some noticeable points. You see, potential is directly proportional to the magnitude of charge. Potential is a scalar quantity. So for positive isolated source charge, potential is positive, and for isolated negative point charge, potential is negative. Potential is also proportional to magnitude of charge. Next, potential follows 1 upon r. Potential is proportional to 1 upon r, whereas electric field intensity is proportional to 1 upon r square. Fourth, potential in a medium, Bp is equal to 1 upon 4 pi epsilon naught epsilon r q upon r. This is the potential in a medium whose dielectric constant is epsilon r. And this formula, Bp is equal to 1 upon 4 pi epsilon naught q upon r. This is the potential in air, free space or vacuum. Okay. So this is all about the electric potential. Okay. Thank you, students. Have a nice day.